Okay, hi all back. We return to the last part of the sessions of today. Aurora, all yours.
Okay, great. So just to reiterate what we're going to be doing next. So we can follow the exact same, you can follow the exact same example that I just did. And now we will be plotting the near infrared data for the same star, WASP-76, from the Carmenes. Yeah, you can follow the same example. I just changed which spectrum I was plotting so I can get a prettier spectrum. So if you want to plot the same one as me, mine's the 2018, October 3rd. And then, yeah, it says here what the time is, so you can check to see if it's the exact same. And now you can see the absorption lines a lot better. And here's the spectrum in all 61 orders. So just do the same thing for the
Aurora,
near infrared.
can you share your screen, please?
Oh, sorry.
Okay, no problem.
Oh, there we go.
Yeah, I thought you were making general comments until I realized that you were speaking about your screen.
Yeah. Okay.
Okay.
I changed the spectrum. You can see it here. It's on the workshop. Yeah, 2018, 10, 3. And now you can see the absorption lines much better. And here's the full spectrum in the 61 orders. And so now just do the same thing for the near infrared. Yeah, I'll probably give you maybe like 10 or 15 minutes to do that. And in 10 minutes, I will update my my example here to show my plot of the near infrared. And then I'll come back in 10 minutes and we're going to download HARPS data. This is the last publicly available archive that I'm going to be showing you how to use today. And then we'll compare WASP-76 spectrum with the HARPS spectrograph and WASP-76 spectrum with the Carmenes spectrograph. So I'm going to turn my camera off, but I will be here. And so you can just send a message, and if people have questions, or you can write to the chat. If you have questions, I'll come back on and I'll turn my camera back on in about 10 minutes. All right.
Hi, Aurora. You have one question on the chat. Aurora?
Sorry, forgot to unmute.
It's okay, no problem. You have one question on the chat, and is this activity is only for Carmines, right? Or which way?
Yeah, so right now we're working on the Carmenas. So I just did the visible, and you can try to do the near infrared. And then in maybe 3 or so more minutes, I'll type up what I did for the near infrared, and then I'll show you. I wanted to get in the last one today that I wanted to show you, which is the HARPS archive. And if we have time, we'll try to do the same activity for the HARPS data.
Okay, perfect. So let's keep waiting for the students to finish their activity.
Yes.
Aurora, you have a second question here on the chat.
Okay.
Okay, it's from Tatiana Acero Cuellar. She says, "I'm sorry, I'm a little bit confused about the data. The data that we are seeing is the spectrum of the star that WASP 76 is orbiting."
Okay. Yeah, so this is a bit confusing about nomenclature for exoplanets. So WASP is a survey, and it looks for exoplanets, and they name the host stars that they find exoplanets around. WASP 76 or WASP 1 would be the first one. And then they call the exoplanet WASP 76b. So you put a little b next to WASP 76. So the exoplanet is way dimmer than the host star. And so you really can't see the exoplanet at all here. So we're basically just looking at the spectrum of the host star WASP 76. Yeah, you can infer the exoplanet WASP 76b, the presence, by looking at the radial velocity shift of the star, and we'll look at that later. But for now, we're just looking at a single spectrum of the exoplanet host star, WASP 76. Okay, and you are all welcome to keep working on your own plotting, and I will just be writing up the plotting in the collaboratory work space that I shared with you, so that you can check what you did versus what I'm doing. So I will just type that up now, and then come back in 2 more minutes and explain to you what I did. Okay, so since there's only about 25 minutes left in the class, I think that I'll show you guys what I did for the near infrared, and then we'll look at the HARPS data quickly. And we can, if you have questions more about this, we can kind of do a review of this for the first few minutes of the workshop tomorrow. Okay, so let me share my screen. Okay. Great. So now I have uploaded a second file. I've called this uploaded to, and this is now the near infrared data. And I can tell that this is the near infrared data because it has this NIR_A. And again, we're going to be using the A files only today. Okay, so then it's been uploaded. And then I wanted to check to make sure I did it correctly. So I looked at the header, but I've commented that out because it was really long again. And again, it's good to just look at all the information in the header and double check that you have the target that you think that you have. And then I wanted to figure out a little bit about what I was looking at. So the file should be set up in the exact same way as the other Carmenes data. So again, the first extension will have the spectrum data, and the fourth extension will have the wavelength data. And I wanted to just see how many orders we have here and how many pixels in each order. So for the near infrared, we have 28 different orders and 4,080 pixels per order. So it has fewer orders in the near infrared. And then I plotted those again with a for loop. And I just looped through every order and plotted the wavelength versus the flux. And that's what's shown here. So we can look at the wavelength coverage here. So it goes from a little bit blueward of 10,000 angstroms, which is the same as a micron, all the way to 17,000, which is 1.7 microns, which is kind of the end of yeah, this is kind of like Y and J band. And you can see a big difference here between the near infrared and the optical data. You have this pattern where you have this area where you get a lot less flux here. And we didn't see any kind of pattern like that. It's kind of hard to tell. There's a lot more flux in the blue part of the spectrum, but we don't get any of these giant dips. And that's because in the near infrared part of the spectra, and again, we'll talk about this a lot more later in the course, but in the near infrared part of the spectrum, there's a lot of absorption from water. And so that's what's happening here is you're getting lots of atmospheric absorption from Earth's atmosphere getting in the way, and a lot of Earth atmospheric water absorption. Okay. Looks like Aurora, I did see a question.
You have one question here. It's from Armando, and he says, I got lost. What does the color are representing?
Sorry. Yeah, I should have said that. The colors, matplotlib, when you just have it do a loop, it plots each time you do a new plot a different color. So I can just specify the color and have them all be blue. Maybe that looks more like a spectrum that you're used to, or black. So yeah, it just, every time that I do a loop, matplotlib just automatically uses a different color. The colors didn't mean anything. And we can, let me zoom in on, yeah, maybe like 10,000 to 11,000. Yeah. Okay. So yeah, here's our spectrum. The colors didn't mean anything, but again, we can see a lot of these absorption lines here. Okay. And the last data archive I wanted to show you is the HARPS data archive. So if we go to the notes, can copy that. And it should bring you to this form, which is now we're looking at the ESO archive. And it's kind of similar to the other archives we've looked at so far. So you just kind of have to type in your title, or sorry, your target. And again, we're going to look at WASP-76. This is an exoplanet host star. And try to compare what the HARPS spectrograph looks like compared to the Carmenes spectrograph. They're both high resolution optical spectrographs, but we can see what the difference in wavelength, coverage, and resolution looks like. Great, so we put in the target name so we don't have to put in the position. And the important thing that we want to check is that we want the HARPS instrument. So if you go through to instruments, we can click HARPS. And then again, you can specify an observation date, an exposure time, anything like that. But we don't need to do that. We'll just try to get all of the data. Great, okay. And there's lots of data again. HARPS has taken lots of spectra of WASP-76. So let's just try to download one. Wow, there's a lot. Let's do something a bit more recent. So you can see the dates here. The first ones were from 2014 and all the way at the bottom, 2017. So let's do something from 2017. And now in order to download the data, so I can check that I want this file. I've just chosen a random one from 2017. And then I have to click Request Marked Datasets. And then I can say just the instant download. And I submit it. Oh, you know what? I just realized that I have an account and I'm not sure if you need an account to do this. So if somebody would comment if they can do this without an account, that would be great. I'll just keep going, but comment if you cannot do this. And so then if I just click on it, returns the selected data set, and then I can just click on it to download. But let me know if you can't do that. I'll just assume that we can for now. Okay, and so we have about 15 minutes left. And so basically what I want you to do in the last 15 minutes is do the exact same thing that we just did with the visible data and the near infrared Carmenes data. Okay, you need an account. Okay, so I will just show you what I'm doing. And then it's free to make an account and anybody can make an account. So if you do want to do this on your own, you can make an account and then we can start with this tomorrow if this is something that you're interested in and doing some data download from HARPS. I think it's good to explore different ones, but I'll quickly just plot it just to show you what the HARPS data set looks like. Okay. So let's upload a third file. And this will just take a second. Great. Oops. So now I will make a hearts file. And here's the file name. And I'll look at the header quickly to check to see if I've uploaded it correctly. Oh, uploaded 3. Okay, great. Seems like I've uploaded it correctly. And again, it has a very long header that you can scroll through and see. But I will just comment it out. And the challenging thing when you're working with high resolution spectra that have been reduced differently is, again, that they have their data in different places. So HARPS might not have their data in the same place that Carmena's does. So let's see what the header looks like. Okay, so in the first extension, they have the wavelength, the flux, and the error. So all of that is in the first table. So then in order to plot it, I can plot the wave. Let's see. Actually, before we plot it, let's see what the dimensions are. Okay, so it's just a single array. So it looks like so another thing that you have to know when you're looking at spectral data from high resolution from these pipelines is sometimes they'll do some steps and sometimes they'll do others. So they've combined all of the orders into one. So this makes it really easy to plot. Okay, so I'm plotting, oops, the wave data versus the flux data. And this seems to be taking a minute. wasn't called Flex. What was it called? It was called Flex. Okay, try again. It might just be too big to plot since it's so many. We'll just plot the beginning. So you can use another bracket to plot different, or to choose different areas of the spectrum. So I'm worried that there's too many pixels of it trying to plot. Oops. Okay, well, it's having trouble plotting such a big file, I think. And there's only a few minutes left. So I'll probably try to revisit this tomorrow during our workshop at the very beginning, just to kind of show you what I wanted to show you about the different, comparing different data sets. And just so you know, if you do want to download any of the HARPS data or any of the data from the ESO archive, anybody can make an account. It's really easy. You don't have to be, you don't have to be like a PhD or anything like that. And then you just have to put in an email address, and then you can download any of their data. And so it could be really fun to check this out and look at some of the data yourself. And again, tomorrow I will finish up with some of this and try to get it to plot better. It seems to be lagging here. So if there's any questions in the last few minutes, I'd love to answer any questions that you have about what we've done so far.
Yeah, so far I can tell there are no questions on the chat, at least that I can see here from the moment. If you would like, we can share your email address, and then if they have questions, they can send you an email.
Yeah, that would be great.
If you can pass it through me, please, to the chat, our chat. Then we can put it on the screen. So if you have any questions regarding the topic of today and plotting and downloading the data, you can write an email to Aurora, and she will be happy to answer your questions.
Yes.
If there are no more questions for today, then thank you very much. Thank you, Aurora. Then let's see you tomorrow at 2 p.m. your time, 8 a.m. our time, local time. And thank you very much for everything you have been taught today.
Great, thank you. I hope it was useful. And now you have the worksheets. They have all of the data archives, so you can use them in the future.
Exactly. Perfect. Thank you very much. Remember that you can do the exercises by yourself. You have the link for the collaboratory that she shared with us. So you can try to reproduce what she did and try to compare everything which she had. Thank you very much, and then let's see you tomorrow.
Bye. Thank you.
Bye.